you're given a list of airline tickets where tickets I from to where tickets I is an array of two elements from and to represent the departure and the arrival at airports of one flight. Reconstruct the itinerary in order and return it. All of the tickets belong to a man who departed from JFK, thus the itinerary must begin with JFK. If there are multiple valid itineraries, you should return the itinerary that has the smallest lexical order. Smallest lexical order when read as a single string. For example, in the itinerary, JFK LGA has a smaller lexical order than JFK LGB. You may assume all tickets form at least one valid itinerary. You must use all the tickets once and only once. Okay, so I'll just close this. I'll try thinking of an example. Let me just copy paste this into here. I should have done that from the beginning, probably. That's kind of annoying. There we go. So if we start with JFK, that's the example. And then what? So if you have JFK LGA, for example, and that's going to be a substring. Okay. Now we want to add more things. So from LGA we can go to, I don't know, YYZ. Is that Toronto? I don't know. Man, thinking of a good example is difficult sometimes. I know every ticket must start from JFK. The itinerary must begin with JFK. And then this say you may assume all tickets form at least one valid itinerary. Must use all tickets once and only once. So we can assume that there's... What if there's like something like this? Is this possible? LGA, LGB? Because then that wouldn't really be a valid... form at least one valid itinerary. So maybe this is okay as well. You can go for LGA to YYZ or LGA to LGB. If there are multiple valid itineraries, you should return the itinerary that has the smallest lexical order when read as a single string. So there are considerations that there's multiple itineraries. Okay. Right? There are considerations, and if this is the case in the smallest lexical order, what other like scenarios do we need to consider? We know it starts with JFK. Can we have multiple JFKs? And thus multiple start points? Multiple JFKs? I mean, just things to consider. And it must begin with JFK. Does it need to end somewhere? I don't think it needs to end somewhere in specific. I didn't read that. Okay. I let me try putting some more kind of examples. I can do like a from YYZ to back to JFK, for example. So what would I return in this case now? Would I return the smaller lexical order? So would I return JFK, LGA, LGB? Because that's the smaller lexical order. The other one is the longer path. JFK, LGA, YYZ, JFK. But YYZ and LGB, if you take a look at those lexical orders, LGB is a small lexical order. So even though the other one is longer, I don't think that really changes anything. Yeah, I think the answer would still be LGB. I'm like really tempted to look at the example here, but like, I just want to like, it's so important for me to, it's so important to be able to come up with these examples on my own. I guess I'm just scared that my example is not exhaustive enough. But you know what? Let's get over that fear and let's just keep on moving forward. So I've considered like kind of some like not really edge cases, but just different like scenarios to keep in mind. If there's a multiple JFK, I guess the one that has smaller lexical order would be the winner. And I guess we're coming about the like how would I actually solve this? Well, I would start from any GFK, right? So I'd start from GFK, and then I would, at each stage, I would be like, okay, well, from JFK, the only option I have is LGA, so I have to go to LGA. Okay, then from LGA, I have multiple options. I have the option of YYZ or LGB. So YYZ or LGB. And then from each one, there's like a different path kind of going forward. But from here, if you want to choose the smaller lexical order, you got to choose LGB. So I guess at this point, like, there's some kind of sorting happening. Like, at least that's what I'm doing as a human. Like when I'm at this stage, I'm like, okay, well, LGB is the smaller lexical order, so let's just go with that. All right. But then it says you must use all the tickets once and only once. So this, like if I were to end up with an answer like this, then this causes a problem, right? So ideally, I want to talk with the interviewer and ask, how would I actually deal with this situation? It's not too clear for me in my head. I guess I would have to, if you must use all the tickets once and only once, so I guess lexical order won't even come into consideration then? Is that the situation? Is my answer wrong? Okay, well, JFK, LGA, YYZ, JFK. Okay. So this is the answer we should actually be going for because it satisfies the condition that you must use all the tickets once and only once. This is not valid because it doesn't use YYZ. What if this were JFK? Would that change anything? That doesn't really make much sense. Can from and to be the same departure and arrival? think I'm digging into details that are kind of irrelevant, or maybe they are relevant. I don't know. Maybe. Okay, how would I get to a scenario that uses all of this? Like what I'm thinking is like maybe add a third condition that does LGB and move to YYZ, and that way this would be correct. You must use all the tickets once and only once. Can from and to be the same? So the problem that I'm kind of facing is that even when I use this technique now, there's still this ticket that's being, like, this ticket in particular that's being, oops, that's being discarded, and then this condition says you must use all tickets once and only once. So what I'm gonna do, oh man, should I look at the example? Let me look at the example. At this point, I think the interviewer would help me out a little bit. So we have MUC, LHR, JFK, MUC, SFO, SJC, LHR, and SFO. A good thing to kind of keep in mind that JFK doesn't have to be at the front. But then from JFK, you can go to MUC, then you can go to LHR, then you can go to SFO, then SJC. I guess that's what we're kind of connecting with that with the graph. Nice. Okay, and then the other example here, JFK SFO, JFK ATL, SFO ATL, ATL JFK, like a very cyclic kind of graph, ATL to SFO. JFK ATL, JFK SFO, that's large X lexical order. But JFK ATL, ATL back to JFK, JFK back to SFO, SFO back to ATL, ATL back to SFO. And that uses all the tickets once. Another reconstruction is JFK SFO, ATL, JFK ATL SFO. Let's see, JFK SFO, SFO to ATL, ATL, ATL to SFO, JFK, JFK to ATL, and ATL to SFO. Okay, so it uses all the tickets in here as well. That's such a hard example to come up with. I don't know. I would not know how to kind of come about doing that. Because both of these are invalid because I didn't use one of the examples in here. Like in this example here, I didn't use YYZ JFK. But I guess I can use it now. JFK, like that. Okay. So now I've covered all of them. Right, JFK to LGA, LGA to LGB, YYZ to JFK. Sorry. JFK to LGA, LGA to YYZ. I didn't cover that one. JFK to LGA. LGA to YYZ, that's not covered yet, but LGA to LGB, LGB to YYZ, YYZ to JFK, JFK back to LGA, and then YYZ, and that completes it. The other iteration I have going here, JFK to LGA, LGA to YYZ, YYZ to JFK, JFK to LGA, LGA to LGB, LGB to YYZ. So this one is small lexical order. So I think this is the answer. Okay, so what am I noticing now as I'm going through this problem? I'm like 16 minutes in and I haven't even started. I'm just like trying to understand the problem. Kind of, it's concerning to say the least. My goal is to start the brainstorming phase by like 5 minutes in. Okay, let's continue on. Let's not give up. We can assume there's at least one valid itinerary. You must use all tickets once and only once. So if we do a depth first search on JFK and go that path, on that path, if we come to a scenario where there's multiple, okay, well so this structure I have going on is pretty confusing, right? Why don't I create a adjacency list? It's a common kind of feature of what's it called? Graphs. So from JFK, we have LGA. Any other JFKs? No. From LGA, we have YYZ and LGB. And immediately I noticed that, hold on, this is not the right order we want to be going in. We actually want to sort this. Okay. And then LGB, or let's say YZ to JFK. Okay. LGB to YYZ. And I think that's it. So JFK, LGA, LGA to YYZ, LGA to LGB, YYZ to JFK, LGB to YYZ. Okay. So in this instance where there's two, we have to sort this. Right, sort, and then do a little switcheroo here. So if I were to do that for every single adjacency list, I'll be going through the number of edges and sorting each one of those edges. And then I have to do that for search on all of these nodes. So I'm trying to think about the time complexity. If I were to call it on this first one, then call it on this one. Because, well, we have to start with JFK, okay, with our adjacency list. And then with JFK, we need to pick the element that is the smallest lexical order if there's multiple. In this case, we only have one. So then we go to LGA, then we have this kind of list, right? And this list, we'll have to sort it and then choose the one with smaller lexical order, LGB. And then we go to LGB. LGB. LGV to YYZ. Okay. Then YYZ to JFK. Then JFK to LGA, and then LGA to YYZ. So one thing I'm noticing as well is, okay, so once I get the JFKs, I've reached a node that I've already visited. But there's a path in here that I haven't explored yet. How do I know that I need to explore this path? And there's also this example here. We have JFK, ATL, then JFK. How do you determine that when we get back to JFK, we still have things to continue to explore? Okay, well, I'm one step closer to a potential answer. How do I know? Can't think of a solid way to do this code. As a human, I know that there's still YYZ left. Kind of keeping a mark. Okay, well, if I keep a mark that this YYZ path has not been like accessed, right? I can work backwards. Like I know YYZ goes to LGA and LGA goes to JFK. But like, how do I do that in code? I don't think I can go backwards like that. Okay, explain my thought process. I'm just trying to think of a way to connect YYZ and JFK. Maybe that's too a narrow kind of perspective. Can I take a look at this output here? Also, I never asked if tickets can be empty, or like any of the edge cases. I didn't talk about that. That's not good. There's quite a few things here. Consists of uppercase English letters. From is not equal to 2. Okay, so can from and 2 be the same? No, they can't. Okay. JFK, ATL, SFO, ATL, SFO. We go JFK, LGA, LGB, YYZ, JFK. There's still this one left. So this list over here, as we're going through it, JFK, LGA, we remove this. LGA to LGB, and we got this after sorting. Sorting would be O and log of n. n being the length of this edge specifically. So I'll just say length of edge of this edge, and I'll just call it E. Why not? E. Right, E is the length of this edge. And then we get here LGB. We take this out. No longer anything we have to check. LGA, LGB to YZ. We don't need this. Then YZ to JFK. We don't need this. Now we need LGA to YYZ. How can you get to YYZ? LGA. That I don't know. I'm kind of stuck at JFK because, or we can just like once we reach this part, we can just keep on depth first search until this is empty. Right? That's really all I have to say. This is empty and just ensuring the order that we're going in. I guess we have to pop this once it's used. Or that might cause problems actually. Because I'm thinking like if we pop this off, then how are we ever gonna get to LGA? So when we get to LGA, how do we determine that we want to go to YYZ? I know this mapping here says we need to go that way. And by definition, if we've created this adjacency list, we already know that this exists, right? And depth first search isn't that smart. It's just gonna keep on like JFK and then LGA, and then it needs to determine between between a list of destinations. How does it know not to go to LGB and to go to YYZ? Right, there might be cases when it does want to go back into LGB and then eventually like cross this one out. YYZ. Right, there might be. Alright, maybe my example's wrong. I don't know. We're at 30 minutes. And I don't really have a good solution. I can start writing code, but I'm gonna get stuck. How should I go about this? Adjacency list. I'm being silent for long periods of time as well. This is not ideal. I should be like explaining my thought process. I don't really have anyone to talk with either. Having thoughts that I just won't be able to finish this question. Which isn't great. I don't even have like a brute force solution or anything. These are the thoughts in my head if I have to just keep on speaking. I guess they're not really thoughts I want to be sharing with an interviewer, which is why I would ideally stay silent. Or, not ideally, but just why I would stay silent. But just for the sake of keep on communicating, I'm explaining my thought process, explaining the emotions I'm feeling, which is not the not what you would want to be doing. Let's create an energy simulator. I have 2 minutes left. You know what? I'm gonna stop it here because I do want to be respectful of my own time. I have like a few other things that I want to complete doing. So I am gonna pull up a video and try to understand the conceptual idea of this. I wanted to give myself just 35 minutes to complete this question. Bummer that I couldn't get something, but let's not be too hard on myself. It is a hard question.